Welcome to Chapter 1. I have sent the PDF version of this to you already, so if this is something you need to review or learn because it's been a long time, feel free to print. I sent it so that you can print that out, and everything that you see on these slides are already embedded in that PDF, and then we're just going to kind of go through and fill in. And my idea there is that would save you a lot of writing. And you can see just a really nice, I typed out all the vocabulary words, or I think I have, and we can go through, my goal is to go through this whole chapter in one video session, knowing that you have the ability to fast forward and rewind as needed. So without further ado, Section 1. Section 1 just defines what you see there on the screen: variable, constant, expression, equation. And then we go right into translating expressions. I also have sent out a PDF that just lists a bunch of these. This is a skill that's very nice to have in place. However, it's not a skill that comes up over and over and over again. So in general, you do need to know that things like more than mean addition, but we don't practice this specific skill throughout our course. It just provides a nice kind of stepping stone for other more challenging math skills. So the number in this case is always where the variable is going to be. So you can use n, you can use the first initial of your name. The letter you choose is insignificant, but we need 10 more than that number. And so we need 10 plus x, or we need to do x plus 10. Most of us prefer to have our variable in the front if possible. And since addition, you can switch the order and it doesn't change anything, then you get to pick. All right. B, the same does not hold true for subtract. Less than means subtract. And this is a little bit of a trickier one because the 6 has to go in the back. If you say to someone, how much money do you have? And you say, I have 5 less than 20. Well, you know you have 15 because in your head, think about it, 5 less than, not that anybody would say that out loud, mind you, but 5 less than 20, in your head, you would probably go, oh, that person has $15 without really writing it down on a piece of paper. And so the same holds true when you are trying to write an expression. Less than, the 6 goes in the back, so you have to do the x minus 6. We can get a little bit trickier and add in some parentheses. 7 times the difference. Well, we're going to multiply something. Times is multiply. So we're going to multiply 7 times something. What are we multiplying the 7 by? The difference between a number and 9. So we need parentheses because we have 2 different operations happening here. We have the multiplication and we have subtraction. So x minus 9. If you're confused about where the subtraction and the order of this, because this one was a little confusing, the and is typically where that subtraction sign would go. So a number, subtract 9. D, quotient. Division is always a little bit trickier, especially when we add in fractions and all of that. And so quotient just means to divide. What are we dividing? We're dividing twice a number. So when we do twice, that means multiply by 2. And again, the and represents where that division sign, so divided by 11. Or probably a little bit cleaner, but a lot of students start off kind of skittish of fractions, but that bar in a fraction sign just literally stands for divided by. So between these 4 and you hearing me watch them, work them out, and all of the ones I sent you on a PDF, that covers a lot of that skill. Okay, example 2. Evaluating an expression. Substitute a number for the variable and simplify. So the purpose of having variables is so that we can evaluate at different points, or we can solve for them if it's an equation with an equal sign, and find true values. And so here what I'm going to do is I'm going to just replace this x with a 5, and I'm going to replace this y with an 8. But that's a little bit ugly, and so I'm going to make it neater and show you right here. So I'm going to go 3 parentheses 5 plus 8. And we have, this doesn't come up. This chapter is kind of like you're always putting the cart before the horse a little bit. So we haven't done order of operations yet. That's in 1.8, but we are going to add these parentheses before we multiply by 3. So 5 plus 8 is 13. And 3 times 13 is 39. And our final answer is 39. Feel free to try the next one if you'd like. Pause the video, give it a shot. At any point, I would encourage you to do that. As the course moves forward, I do come up with very specific tries that I intend for you to try. Chapter 1 is just, we have to go through it so quickly to make time for things that are more challenging later in the semester. So I am going to replace x with 3. I'm going to replace y with 4. And since all of these variables are smushed together like that, it implies multiply. So I'm going to multiply all those things. And then at the end, I'm going to replace that z and divide by 6. So let's simplify the numerator. 2 times 3 is 6. 6 times 4 is 24. 24 divided by 6 is 4. Don't get thrown off if sometimes you don't get an integer or a nice whole number or something like that. Sometimes our answers in this class are very gross fractions or decimals, and then that makes students feel like they didn't do it correctly. So I would encourage you to not get thrown off by that. All right, this one adds a little bit of a challenge. If x is twice y, so x has to be double. X is the bigger one. And if x is 32, so if x is 32 and x is twice as big, that implies that y has to be smaller by half. So half of 32 is 16. And so we can substitute that in. 32 minus 16 over 4. And again, before I divide, I would simplify that numerator. And so 32 minus 16 is 16. 16 divided by 4 is 4. And it is a complete coincidence that both of those turn out to be 4. All right. Now we're going to put our translating skills one step further. An equation means that you have an equal sign to your problem. And so again, whenever you see the word is, that is where the equal sign goes. So what number? There's our x added to, there's our plus 56 is 83. Every part of the sentence translates. X plus 56 is 83. And I didn't give you a lot of these in the homework on my math lab, but you don't have to solve them because that's not till chapter 2. So all you're expected to do in the chapter 1 scenario is write it out. You do not have to solve. So practice that 10 less than if you'd like. See if you remember where it goes. 1/2 a number, that 10 less than goes in the back. And then is 50. I think that wraps up section 1.1. All right, so now we're into section 1.2. A term is part of an expression. It can be a constant or a number in front of one variable, several variables. And so it says either a constant or the product of a constant and one or more variables. And so here are just some quick examples of what terms are. And so if you had something like this, this would be a four-term expression or a four-term polynomial. You'd have 1, 2, 3, 4. And so anytime you separate between an add or a subtract, that separates your terms. But again, I don't spend a lot of time on that, but it is in this particular section. So we also talk in this section about the commutative property and the associative property, which don't come up often. So you can familiarize yourself with those if you wish. It's the idea, like I've already mentioned, that you can reverse addition and you can regroup things. And so if you want to look through that, you can, but it is not something that is on the test. What is tested is this distributive property, and this is a skill that comes up throughout our semester. And so the idea here is that if you have a number smashed up against the parentheses, you need to multiply that number all the way through to every term in the parenthesis. And we use this, we've got to use this almost every class period. And so 3 times x is 3x, and then 3 times 2 is a plus 6. Doesn't matter how many terms are in the parenthesis. And I think it's important to note if there are 3 terms inside that parenthesis, there's going to be 3 terms in your final answer. So I have to multiply. You just have to imagine distributing a piece of paper to a class of students. You have to give one to everybody. And so I have to multiply that through by every single piece. And 6 times 7 is 42. Typically, and if you feel this way, I agree with you. I don't like it when the number is in the back. It kind of doesn't look as neat. But if there is a number in the back of a set of parentheses, nothing changes. You still have to multiply it through. You can always choose to rewrite it before you do that. The answer will be the same. But either way you do that, you're going to get 5a plus 20b. So I just want to point out things that I think sometimes students might get thrown by, and it just is such a quick, easy fix. All right, let's check and make sure I didn't write. Now, we distribute again later in this chapter when our expressions get a little trickier and we get to order of operations, but that is it for the moment. So it looks like that wraps up 1.2. Yes, that is all that is in 1.2. 1.3, now we're starting to get into fractions. So, what is a prime number? A prime number is a number that only has 2 factors, 1 and itself. For instance, 5 is a prime number. 17 is a prime number. 23 is a prime number. So those things don't have any other factors. Nothing divides into it evenly. A composite number is a number that has more than 2 factors. For instance, 8. Okay, 8 is, oh, I didn't really leave myself enough room, pardon me. 8 is 4 times 2. And 4 is 2 times 2. And so it definitely has a lot of factors. And so we are going to learn a little bit more about that down here in example 1. Notice the difference in the wording of the instructions. Find all factors of 60 versus find the prime factorization of 80. This right here is known as the prime factorization, where you make this factor tree and you continue to break it down till you can't break it down any further. Finding the factors of 60 is what are all the numbers that go into 60. Factoring is a huge skill for both this course
and your next course. So the more familiar you are with, just knowing those basic multiplication tables and not relying on a calculator, I would highly encourage you to get some of those things memorized and in place. So what goes into 60? Well, when we do the factoring chapter in chapter 5, I like to kind of list it like this. 60 is 1 times 60. It's 2 times 30. So think of all the pairs of numbers that multiply to 60. It's 3 times 20. It's 4 times 15. It's 5 times 12. And it's 6 times 10. And since the numbers between 6 and 10 don't go into 60 nicely, I think that wraps it up. So on my math lab, normally I would say the book, but we're not working out of the book. They're going to have you separate this by commas. So it would look something like this, and then you would just literally list, oops, I needed to write 15 right there. So those are all the factors of 60. Find the prime factorization of 80. So this is going to look more like this. So I'm going to start it kind of up here, knowing how big I write on this slate. And so 80, what goes into 80? You can literally start anywhere you want. 80 is 8 times 10. 8 is 4 times 2. 4 is 2 times 2. And 10 is 2 times 5. So if it was just doing work on paper, this would be totally acceptable. When you have to type an answer into my math lab, I recognize it's not overly convenient. But it is nice when you need hints because you can click that show me button. So how many 2's do we have? 1, 2, 3, 4 2's. And then, oops, I shouldn't do commas, my bad. Talking about one thing and writing something else. 2 times 2 times 2 times 2 times 5. So one is separated with commas, one is separated with multiplication symbols. All right, C. Well, I didn't leave myself a ton of space here. Oh, we don't need it. Find the prime factorization of 19. Well, 19 is just 19 times 1. Like there is nothing. 1 times 19, it's prime. So if this comes up on the homework, you say the number is prime. There is an option for that. And so I wanted to make sure you understood. The number is prime is what you hit. If you'd like to try 343, I would encourage you to pause the video and go ahead and try that. And so 243, I'll give you a hint. It is divisible by 3. It's 3 times 81. 81 is 9 times 9. 9 is 3 times 3. This 9 is 3 times 3. So if you wrote down 3 multiplied by itself 5 times, that's perfect. If you know about exponents, which is coming in section 1.8, 3 to the 5th is what that would be equivalent to. All right, our next skill is simplifying fractions. Oh, it looks as if, I'm so sorry, let me put some right here. So let's start off with 15 over 40. And for our second example, we'll do 36 over 24. I just forgot to write those in. All right, so how is that whole prime factorization going to help you simplify fractions? Because you need to find what common factors you have, because anytime you have a number over itself, 2 divided by 2 is just 1, and so oftentimes we just cancel any common factors. So
both 15 and 40 are divisible by 5. 15 is 3 times 5. 40 is 8 times 5. So if you can see that right away, what that common factor is, it's fabulous, because then we can just cross that out. And so your final answer here is 3/8. On this side, 36 and 24, they're both divisible by 12, but I'm going to go ahead and break this down and do this kind of the long way and show you. So 36 is 6 times 6, and 6 is 2 times 3, which is 2 times 3. So if I broke this down, it would be 2 times 2 times 3 times 3. And if I switch colors here and do the same for 24, just to illustrate why we learned about that full factor thing, because sometimes you don't see all of those factors. And so 24 is equal to 2 times 2 times 2 times 3. And so what we can do here is anytime we have the same factor on the top and on the bottom, we can cancel that, which is going to lead us into multiplying and dividing fractions. And so then we have 3/4. We just simply write what's left. If there is more than one number that's left over, just re-multiply those. If you can hear my dog barking, I apologize. I tried to make everything, so sorry that's happening on video number 1. So I will pause after this and hopefully she will stop doing that. All right, there are some canceling do's and don'ts that I want to make sure that you understand. And so just like the above example, both of these numbers are multiplied, have 4 as a factor, can be multiplied by 4. So when it's a multiplication situation, yes, cancel. Your final answer here is 2/3. When it's an addition situation, you cannot cancel those 4s. That is a huge don't. Because when we learn about order of operations, we need to simplify that numerator, 6/7. And now you can tell that that doesn't have a common factor of 4. And so addition cannot be canceled. Don't just, so many students, if they see something like that, they're like, oh, the 4s match up. Especially, not to get ahead of myself here, but especially if it's like a this. And so then we add in a variable to the mix and students go like that, and that is not the case. That is a mathematical don't for sure. All right. Moving on. So now we're going to multiply and divide fractions. In general, we multiply the top to the top, and we multiply the bottom times the bottom, numerators and denominators. And if there are common factors, we can cancel out common factors. So you can cancel out the common factors either before or after you multiply. Usually doing that before is a lot easier. So here I don't have any common factors. So I wanted to start off showing you that you could just multiply the 2 top numbers, the 2 bottom numbers. You're going to get 10 over 3 times 7 is 21, and that's all you can do with that. On B, also pretty small numbers, but I threw in divide. When you divide fractions, you change it to multiply, and you flip the second fraction. So if you want to make a note of that, when you divide fractions, you change it to multiply, and you flip the second fraction. flipping is not the most mathematical term. It's known as the reciprocal. So you flip or write down the reciprocal of the second fraction. And I am going to send you, or I've probably already sent you by the time you see this, a PDF of some of these basic skills typed out really nice and neat. And so you do have a bunch of reference. So when I'm just doing some of these scribbles here, you do have an additional information to fall back on there if you want something in more of a table kind of situation. So we've written down the reciprocal. 1 times 3 then is 3, and 5 times 4 is 20, and there are no common factors there, so we are done. All right, now we have somewhere there are some common factors. What two factors go into both 10, or what factor goes into both 10 and 25? Both are divisible by 5. So if I take out a 5, if I divide 5 into 10, I get 2. If I divide 5 into 25, I get 5. Between 9 and 18, both of those numbers have a common factor of 9. 9 divides nicely into both of them. 9 divides into itself once. 9 divides into 18 2 times. And now we rewrite what's ever left, multiplying the numerators and multiplying the denominators. So 2 times 2 is 4. 1 times 5 is 5. And that is our final, most reduced answer. Here, again, we have a divide. So caution, because sometimes that sneaks up on you. And then you don't remember to write the reciprocal. So we're going to change it to multiply. And the 9 is now going to be on top. So I do a lot of examples with 5 because a lot of us recognize the multiples of 5. 5 divides into itself once. 5 divides into 25 5 times. 9 and 6 are both divisible by 3. 3 goes into 6 twice. 3 goes into 9 3 times. 1 times 3 is 3. 2 times 5 is 10. And that wraps up that one. E, I wanted to throw one additional one. It's hard to show you every example of every type of problem you might ever see, but I tried to be thorough here because some students, like what's with the 14? Any number that's just a whole number or an integer, you can put a 1 underneath that number to make that in fractional form. And so now that you see that, if you want to use this as your try, pause the video, try it on your own. And if you tried it, let's see how you did. So both 7 and 14 are divisible by 7. And I see that 12 and 2 both are divisible by 2. The problem here, don't get tricked, the problem here is that both of those numbers are in the denominator. So you cannot cancel things that you are intended to multiply together. So 1 times 1 is 1. 12 times 2 is 24. So if both numbers are in the numerator or both numbers are in the denominator, canceling is not permitted. So my final answer there is 1 over 24. All right, what do we have next? Now we have adding and subtracting fractions. Okay, so this is going to dive into the topic of finding a common denominator or a number that both of my denominators divide into. But in general, notice here that if the denominators are the same, these numbers have to be the same, then we just add whatever is in the numerator and maybe subtract. So 1 plus 1 is 2, and we do not change the denominator. That always stays the same. So that continues. If we have 1/6 plus 1/6, we have 2/6.
So we're adding the numerators, the denominator does not change. Now, we do need to check that we need to reduce that if possible. 2 goes into itself once, 2 divides into 6 3 times. So our final answer here, it's always expected that you reduce your fractions. All right, so that's the idea behind adding. For the rest of our examples, you can tell that I chose not to have common denominators. So we need to find what's called the lowest common multiple, aka the common denominator. So between 5 and 10, we need to find a number that both of these numbers divide into. Well, 10 does technically divide into itself, and since 5 goes into 10 2 times, 10 will suffice as our common denominator. And so this fraction here remains unchanged, and so 7 over 10 here is going to stay 7 over 10 there. Oops. Sorry, now we're stuck with that. I forget. My recording button here is over my back button. Sorry about that. And so we'll need to keep that the same. But then I need to ask myself, okay, how am I going to get from 5 to 10? What number do I need to multiply by? Well, 5 times 2 is 10. And if I multiply the bottom of this fraction by 2, in order to keep the value the same, I need to multiply the top of that fraction by the same number. So 1 times 2 is 2. And now that my denominators are the same number, I can perform the operation on the top of the fraction. 7 take away 2 is 5. And if I need to, I can reduce. Reducing to 1/2, most of us are pretty familiar with things that reduce down to 1/2. So I can take a 5 out of both the numerator and the denominator, and that reduces. All right, let's try that a couple more times. As I scroll down, you can see I have several of these. If we want, I can kind of skip to D. It might seem a little bit easier than C, so I can jump over here first. Sometimes when you go to find a common denominator, it doesn't work like this at all. Like 5 went into 10. Well, these don't have any common factors, and so when that happens, in some ways it's easy because we just multiply them together. So 3 times 2 is 6, and that's going to be a number that both of them divide into. So what do I need to multiply 3 by? Well, 3 times 2. So I got to multiply the top here by 2. 1 times 2 is 2. 2 times 3 is 6. So now I multiply the top by 3. 1 times 3 is 3. And because it was addition, it clearly stays addition. And so 2 sixths plus 3 sixths is 5 over 6. All right, 8 and 12. 8 and 12, you can multiply these together. Like here, you would get 96. You're going to get a really big numbers to deal with and have to reduce. But if you don't see any other way, you can do it that way. This multiplying situation will work. However, we can find something slightly smaller. And so, for instance, 8 times 3 is 24, and 12 times 2 is 24. And so 24 will act as a nice, much smaller common denominator than 96. And some of this, again, just comes from your familiarity with kind of the multiplication tables and such. And so sometimes you have to write a list out like this till you find something.
Honestly, fractions are not an everyday occurrence, but it is a skill that everyone needs to have in place when you're moving on to college algebra. So 8 times 3 is 24, so we multiply the top by 3 and we get 15 here. 12 times 2 is 24, so we've got to multiply the 7 times 2 and we get 14. And so we add those together, and so my final answer here is 19 over 24. You can pause the video and try this one. Keep in mind it's subtract. I went back to our first example and gave us one where 9 is the common denominator. So that first fraction will not change. The second fraction needs to change to a 9 because 3 times 3 is 9. And so I can multiply the numerator by 3. 1 times 3 is 3. And now I have that common denominator, so this stays a 9 right here. 4 take away 3 is 1. So that rounds out 1.3. Okay, I think I'm going to pause the video here, and if you're continuing to watch through chapter 4, I just want to split it up for people a little bit. So that'll do it for that one.